Hey folks, my name is Steve. I do product design and management at a small little startup in San Francisco called GitHub. I want to talk to you today, actually not anything about GitHub specifically. Well, there's one thing about GitHub, but I want to talk to you about Git, because if you're doing software development these days, more than likely you're using Git. How many people use Git? Yeah, that's basically everyone. So how many people would call yourselves experts at Git? Yeah. Yeah. This is most of us, right? Like, so many of us, it's just like, we use Git because we have to, right? We know it's a good thing to do. We're not really sure why. We got into it. Probably, I mean, some of you may, did anyone start with Git? Yeah, a couple people. If you've been developing software for any period of time, more than likely you started with something else, like Subversion or Team Fortress or Mercurial or something down the road. Hopefully nothing before that. So Git actually is, what I want to talk to you today is not about how to use Git, because you probably already, all of you, you're saying you're using Git, you already know the basic Git commands, right? You're using it day to day. It works. Sometimes you don't know how or why, but it does work. What I want to talk to you today about is I want to give you a little bit more insight into a little bit of the mental model of how Git actually works under the hood. Not too deep. We're not going to get too technical and stuff. There's no code or anything. We're not going to talk about that. What I'm going to try and give to you today is a little bit of a visual picture about how Git actually stores your information and its thought process about how commits and various things work, okay? So that way when you go to use some of these commands in the future, you actually can know what's going on and be a little bit more confident in what's going on. So the first thing I want to talk to you today about is trees. Git is 100% about trees. And what do I mean by a tree? A tree in the language of Git is just a directory of files. That's it. Just a directory with files and folders in it. That's it. That's all a tree is, right? It's just a list of files. It's just a folder on your computer with stuff in it. That's a tree, okay? And that's all these things are. When we come from a world of something like Subversion, a lot of times we think of commits as like a moment in time and some changes to some files, which in some ways they are. But in Git, every single commit is a tree. It is a representation of an image of that directory of files in any point in time. That's what a commit is. This is a very important distinction. A commit is not just a message with some changes in it. A commit is actually a snapshot of that directory at that moment of time. And it's really important to think of it that way. So I want to give you a little bit of visuals. We have a working directory here, right? This is a Command N on your computer. New directory, it's empty. And we're going to dump a couple files in here. Okay, file 1, 2, and 3. This is a tree, right? This blue box right here is a tree. It's just a group of files in a folder on a computer. Awesome. We go into that directory in a terminal or whatever Git thing you want to use. We do git init. So let's make a new Git repository. Sweet. When you create a Git repository, here's what you get. You get two additional things. One, you get this magical thing called an index. We'll get into that in a minute. And then you get what's called head. In Git, head is just pointing to something. Usually, 99% of the time, for a lot of you, probably 100% of the time, head just points at a branch. A branch actually just points at a commit. So it kind of, it's like a symlink all the way down just to a commit. But because we just initialized this repository, our index is empty and our head is non-existent, right? These are just trees. Index is a tree, head is a tree. So now that we have our empty Git repository, how many people have run git status? This is a common command we all do. When you run git status, you'll see red files and green files listed here, right? As long as you have color in your terminal. But you'll see untracked files and chain modified files, right? Green stuff and red stuff. You know what that is? this. Anything in red is the difference between working directory and index. Anything in green is the difference between index and head. That's it. That's all the red and green is. So when we look back at our thing here, we can see red is file 1, 2, and 3, because to go from here to here, this is the difference. File 1, 2, and 3 exist over here, and they don't exist over here, right? So index is just a tree. Index is just a directory. There's this sort of magical imaginary directory that exists. The easiest way to mentally understand the index is the tree of files that I'm going to commit. That's what will become a commit. So this is another command we run a lot. Git add file 1. You know, git add something. If you come from a subversion world, I was having this discussion earlier, this is a new step for you. Usually you don't have to do this. In subversion, whatever you commit, or whatever you change when you commit, you just get everything you want. Git isn't that way. So when you git add file 1, what is that actually doing? It's just adding file 1 to the index tree, right? It's as if you had this other folder and you copied that folder over, or that file over to that index folder. That's it, right? So now when we do a git status, we see, hey, new file, file 1, it's green. Why is it green? Because between here and here, oh, well, we have file 1 in both places, but we don't have file 2 and 3, so those are red. From here to here, we have file 1 here, but not there. So that's green. Very cool. Easy enough. So let's actually make a commit. So we make our initial commit, we get a SHA. What's that actually doing in the background? This. It gives that index a SHA. It copies that tree. It basically formulates that tree as a snapshot at a time and points our master branch at that commit. That's it. That's all it is. The index is exactly what's going to get committed in the future. So let's go through. We'll add file 2 and 3 to our index. Boom. So now when we do a git status, well, let's forget what status. You know that already. We'll just go ahead and make that commit. Here's what happens. That index gets copied. It's given a SHA, which is a string of characters that it should be 100% unique in the history of time, ideally. And then we make this little dotted line connection. Anyone know what that dotted line represents? Anyone? Parent. So every time you make a commit, when you make a new commit, that new commit is assigned what's called its parent, which is just the commit that was at head before. That's all. Pretty simple. You can actually get it way more complicated, but don't worry about it. So now, if we do a git status on this, all working directory, index, and head are the same thing. So there's no status, right? Nothing has changed. All three of these trees are the exact same. So there's no status. So let's make a change to file 1. So we're going to make a second version of file 1. So don't worry about the colors. The color doesn't mean anything except for the fact that it's different than it was before. Don't worry about it. So now our git status says that we modified file 1. It's red because it's between there. We add file 1. Boom. Now our new version of file 1 is in our index tree. We look at our status. It's green now because the difference between the index and the head has that change. We commit that. Gives it a SHA, boom, moves it over, sets the parent, we're done. Right? That's exactly what's happening, is we're just copying these folders, these trees of files, all over the place. And those trees get some metadata inside of the Git repository. They get a SHA, they get a message, and an author, and a bunch of other information. But in essence, they're just copies of the directory. That's it. The magic of Git is it's smart enough to understand how to store all that stuff underneath the hood to do it efficiently and well. But all these are just copies of directories. That's it. So, knowing that, how many of you have used git reset? How many of you have felt good about using git reset? Sometimes it's awesome. Except for the fact that there are 3 kinds of reset, and a lot of people aren't ever really sure which one should I use. there's soft, hard, mixed, like which does which. If you have this mental model of the 3 directories, working directory, index, and head, reset gets stupid easy to understand. So let's look at the 3 different kinds. Let's start with a soft reset. All soft reset does is move where head is pointing to. It moves the commit that the head is pointing to. So let's say get reset dash dash soft. You have to pass the soft flag. The default is mixed, so you have to pass the soft flag. And we get a little syntax shorthand here, which is head tilde 1. That means just the previous commit that head is on. So the parent of commit 1. Yeah?
So it does nothing if you don't pass it some sort of hash, because it just
correct.
Gives you without head tilde 1.
Yeah, a soft reset without pointing it to a different commit than head does literally nothing.
Okay.
So if you do this, so you say I actually just want to go back to the previous commit. I want the last commit to be the one before the one I just did. So I made a commit and I'm like, shoot, I messed it up. What you probably want is a soft reset, because what a soft reset does here is just go, whoop. Cool. It doesn't affect the index, it does not affect the working directory. So what's cool is, we said git commit this, and it created the new thing and moved that tree over. If you just git reset soft to head tilde 1, your index is still the same, your working directory is still the same. So if you just like accidentally forgot to add a file, or you're like, ah, shoot, I should have changed that one thing. A lot of people tend to like to use git commit amend for that kind of thing. I don't actually like that. It makes me understand both of the things at once. The new thing I want to do and the old thing that I did. Doing a soft reset actually just leaves the index exactly where it was, and sets it right back up to where it was before. Anything that was staged is now staged. Anything that wasn't, isn't. And I can then just continue to make my changes as if that commit had never existed. Don't worry, it does. We'll get to that later. Yes?
Sorry. So your index then, if you were to do a git status after git reset soft head tilde 1,
yep,
would show all
exactly
the
stuff that you did that was there right before you made that commit.
Sorry, my mind did.
Right, because it's just a copy of that tree.
This
This didn't change at all. Because you copied this tree to head, and then this just got pointed differently. Now you're at the exact same place you were before. It's kind of amazing, right? In fact, I use this command so much that I actually make a global alias for this, and I recommend that you do this. So I git config -- global alias.undo reset soft hit tilde -1. So now whenever I screw up, I can just do git undo, and it undoes that commit. And I can change it. I can reword the message. I forgot to add a file, or I added too many files, or something, and then I can recommit my stuff, and I'm right back where I need to be. Okay. So a mixed reset. What does a mixed reset do? Well, a mixed reset moves head, and it updates the index. So a mixed reset goes the opposite way. Well, it continues flowing back to where we started from. So if we git reset head tilde 1, so the exact same thing we did with soft, just negating the -- soft. Remember, mixed is the default. It looks like this. So we copy the SHA, and then we copy that tree to the index. That's exactly what a mixed reset does. So if we added a bunch of stuff, and then committed it, and we're like, actually no, I want to change that. And in fact, I want to wipe out a bunch of the stuff, all the stuff that I had staged. I think I just screwed the whole thing up. I want to start over again. Remember, it doesn't affect your working directory at all. So any of those changes that you had made and committed are still there in the actual files that you're working on, right? So you can re-add files, you can change some stuff, add new stuff and make a commit, move things to the index and back to head. But that's what a mixed reset does. So it not only resets the head to a new commit, whatever you specify, but it copies that tree from that commit to the index. That's a mixed reset. You can do this too. So git reset head. Can you imagine what this does? If resetting the head, remember we set a soft reset to just plain old head, doesn't do anything. But if we know that the mixed reset goes back to the index,
this is essentially git unstaged.
Correct.
Or unstaged.
So now we just copy head back over. So we added a bunch of stuff, and we're like, crap. I added a whole directory that I didn't want to add. and I actually just want to start over with like the thing that I'm going to commit. You can git reset head, and that basically sets the index to what head is now. So you can re-add everything. You can actually, most of the time what I do is, I hardly ever reset the whole directory, but I will do a certain file. I added something, and I ended up not wanting to add that file into the index. So I'll reset the head, that thing. I do this often enough that I actually have, I add another global alias called unstage, right? Because it turns out git add, git is terrible in this terminology is the worst, because you git add something to add it to the index, you git remove something to remove it from the working directory, which is not what you would think it would do. Git doesn't have an so adding it adds to the index. Unadding something to the index is this. So you can alias unstage to reset head. So now you add something and then you can git unstage that file. So instead you can either git unstage or unstage a particular file or a regex match, for instance. So if a soft reset only affects the head, a mixed reset affects the head and the index, you can imagine what a hard reset does, right? Careful. A hard reset is the only thing, one of the only things in Git that you can do that causes data loss. Because a hard reset affects your working directory, okay? And your working directory is the beginning of everything. And there's no, unless you have a backup through Time Machine or a hard drive or whatever else, that working directory is the sacred thing. You don't want to mess with that. So, but if you do something and you realize like, I never want this again, and I screwed up a whole bunch of stuff, and or I tried doing a merge from some branch, and now my whole directory is screwed up, and I just want to get back to where I was before, you can do a hard reset. So hard reset head tilde 1 does this. We reset head, and then we copy that tree both to index and the working directory. We start over. We set everything back to where it was before. That's what a hard reset is. Use that with caution. But there are times when it's actually super nice and important. You can also just do that to say, get me back to where I was, right? I may not re-point the head, or I may not want to point head to anything else, but I just want to. I have this last commit, and I tried doing some stuff, and it totally didn't work. But so I just want to erase it all and get back to where I was. I don't do that. There's much better ways to do that. Don't ever do that. So if you have a commit, you don't want to change that commit, you don't want to reset head, but you did some stuff and then you're like, I don't know if I want to do things that way, or something is a little weird with it, I probably won't ever use that, I'm just going to start over. Don't do a hard reset because it's data loss. Those changes that you made are gone forever. Instead, stash. So, if we're in this state, right? So let's get our bearings with this state. We have a head and an index that are the same. So there's no and we have a change to file 1 and a change to file 2 actually. So in this case, file 1 and 2 are unstaged, and we have an index and a head. And we're like, actually, I tried this stuff. Like I ran my tests, or I like loaded up my test environment, and it just it's not quite what I wanted. Instead of doing a hard reset to write over that and just get back to where things were before, it's much easier than just like undoing, holding down Control-Z on every file. Don't hard reset, because that's gone forever. Instead, git stash-u. You can even save it with a description if you want. Git does an interesting way of trying to assume and label what you're doing. If you want to do this and you even think that you may want to come back to this stuff later, you're like, I tried this and it's not quite what I want. But you know what? I'm sure all of you have made that decision before where you're like, that's junk. And then you work for like another 5 hours and you're like, actually, I kind of wish I had that back. That actually was not a bad way of doing it, and maybe I would like to get back to where that was and maybe change some stuff. So you can git stash-u save description, and this is what happens. Boom. So git stash creates a separate like a tree of the working directory in its own little separate area, and then it does a hard reset. he will store these changes for you in a list somewhere, and then do your hard reset. That's exactly what a stash is. Okay? So let's continue to make some changes. Like we changed, so we have these changes. We're going to change this one again. We're going to add file 3. Now that changed, so we changed file 3 here and here. We commit that. Commit that so we get a new head. So now all these things here are fine. When we git stash list, we can start to see a list of all the stashes that we've done. And if you happen to label it correctly, you get a nice little description of what's going on. Looks oddly like sort of like a commit log, right? It's basically what it is. It's just pointing at a tree. It's just not in the head area.
Does it not come with a timestamp?
They do have timestamps. I think you have to pass a format if you want to get more specific information, but it does have, it is in essence exactly a commit. It has a show just like everything else, like this here. So when you list it, and then you can git stash show, or a particular version, stash at 0. Then you can git stash pop. Git stash pop says, take that tree and merge that tree with my working directory, just as if you were to do a git merge from branch into some other branch. So if we git stash pop, you'll notice we have new versions of file 1 and 2 here, and then a new version of file 3 up here. When we git stash pop, it actually just blends all that stuff together. And if there are merge conflicts, it will just create the conflict in the file and let you resolve it, but you're not in the middle of some weird merge where you can't commit things weirdly, whatever. It just adds the conflicts into the file. They're really easy to solve at that point. Okay? But beware, git stash pop, this thing is now gone. So if you were to do another hard reset, it's gone. It literally pops it off that list, and it's gone. Which is why I never use pop. I always git stash apply. Because git stash apply does that exact same thing, but it leaves this one here, right? So that way you can try a bunch of stuff, and if you don't like it, you can reset and git stash apply again and start over. Like, I do as much as I possibly can to keep all of the changes that I make around in Git, okay? Getting rid of stuff is dangerous. So git stash apply is a much better way to do it. You can even, if you realize that a stash that you had is really good and you want to continue working with it, you can actually git stash branch your new branch name and stash at 0 or 1 or whatever one you want. And that will actually create a branch directly from that stash with that branch name and get you at that point in your new branch. Pretty amazing. So that's stashing. The ref log. How many people have heard of the ref log? Sweet. The ref log is amazing. The ref log is simply a meta repository for your repository. You'll notice we have this set up. So right now there's no git status is nothing. Our working directory and index and head are all the same. And if we reset head hard, let's do a hard reset. Cool. Did I skip? No, okay, I didn't skip over. So we did our hard reset, and we git log. So now when we git log on our branch, we see the 2 commits that we made. Where's that? Where's that other commit? Like the third one that we had. This is what people are really scared about with resetting. Is, well, I had this commit, and then I did a reset. Now where's that commit at? Okay. Git ref log. A ref log is a literal log of every change that you make to head, ever, in your repository, at least for a non-insignificant period of time. We're talking months, right? So you can see we made our initial commit, we added files, we modified it, and then we reset to head tilde 1, same thing. So if we actually wanted to get this commit back, let's say actually, shoot, I did want that, and I want, I want those changes. We can get either one of these, head at 1 or this SHA that we get from this thing. And we can say git reset hard to that SHA. And boom. Now our log has that commit again, right? Because that commit knew its parent was this one, and now we just point it back and we follow our parent tree all the way down. The ref log lets us get at everything else. We can create a new branch from that. If we're like, well, I didn't want that, I want that change that I made to that one branch, but I actually want to start it off in a new one. I didn't like it, I reset that old branch and I create a new branch from that thing, right? You can get really complicated with this, but in general, every commit that you make will stay in the ref log for a long time, if not forever. You can even show the ref log for a specific branch that you're working on. So I forget about every other head that I've changed, but I'm working on this feature branch that I want to do. Show me the ref log just for that thing. What changes to head on just that branch that I made? You can even do stuff like this, like get ref log show a branch name, like at 1 week ago. So I know I made a bunch of changes this week, but I knew I did something last week that I want to get back to. And it's not in my, I reset it somewhere or I made something and then I changed a bunch of stuff and I know I did it last week. So I can look at that and it will actually give me a list of things that I did 1 week ago. This is actually, this is a part of Git that's written in Ruby, so this is the exact Ruby syntax. So you can do 1 week ago, 1 month ago, whatever. So that's getting at the ref log, right? You will not lose commits within a period of time. And if your repo is small enough, probably forever. If you have questions about how that might get lost, we can approach that later. Interactive rebase. Who's tried an interactive rebase before? Yeah. This is honestly my favorite thing to do. It's so good. Why is it so good? Because it makes me look like I know what I'm doing. Not to me, or during the interactive rebase, that I don't care. No one watches me do the interactive rebase. What makes me look great is the commits that I push up to the server look perfect. Because I don't know about you, but I screw up a lot when I'm developing, and I like to make a lot of commits because I don't like to lose stuff. So this is typically what happens when I do a git log on a feature branch. These are what my commits look like. So oh yeah, I'll fix my display bug. It fixes issue number 145. Great, I got that one fixed. On to the next thing. All right, I'll update some comparison text. Cool. Crap. This one actually fixes the display bug. I hate to say, wait, nope, that one didn't work either. All right, now I'll get some better markup for the container. When I change that, I notice God, display bug. Damn it. And then oh God, that was it. God. So this is my log. This is what my Git log looks like, right? Because I'm not very good at being diligent. Interactive rebase lets me change all of this into something amazing. So this lets me. The important part here: interactive rebase before you push. Don't be too jealous to push code up after every change that you do. You can do a lot with keeping stuff locally and then pushing it up when you know you're done with stuff, or at the end of the day, or something. You don't have Git is a distributed version control system. It's very good at handling stuff. You don't have to push stuff up to the server every change that you make. And this is why, because I can actually change this history. I can rewrite my history of how I worked on this thing. So I know I did about 8 commits on this thing, on this feature branch. So I'm going to git rebase -I. So this is your interactive -I. And then head tilde 8. So 8 commits ago or so. Just give me those. And this is what you'll open up in your editor. It will look something like this. So there's some details down here which are actually your instructions for how to do this. And then this. So here's what this means. When you have this list of things, pick just means I'm just going to use that commit. I'm just going to be yep, make that commit. Reword will actually open up. It'll make those changes. It'll update the index and make that commit. But it'll open your editor just as if you had just typed git commit. Boom, and you type in your commit message. If you want to change the commit message, basically, you just want to reword that message. Okay? Edit means it will literally stop mid-interactive rebase. You can modify some files, add things, and then say commit, and then git rebase continue, and it will then continue doing the rest of the stuff that you added. A lot of this stuff gets really, like this is probably pretty technical, and I hardly ever do this. What I do use a lot is squash or fix up. So squash uses the commit, but instead of, it doesn't add it as its own commit, but it will it'll add the commit message, it'll combine the two commits together. So it'll combine the changes from both of those commits into one commit, and it'll take both commit messages and put them both in the same commit message. Okay? So it turns multiple commits into one thing. Fixup is the one I use most often. It does just that same thing, except it just uses the commit message from the first commit. It doesn't continually add commit messages. And X lets you execute commands, so if you want to do an interactive rebase, you can actually, and if you think you did something to like run your tests or something in the middle of stuff, you can try that. Yes?
So I've used squash a bunch of times because I like the fact that at the end it shows me all the messages, and then I can, like, well, I need part of this one and part of that one.
Yep.
Does fixup, what do you get when you do fixup? Do you even get back to an editor before it?
No.
Okay.
Nope. Fixup just says like so this is where I arrange everything where I'm like, this is the commit message I want, or like I'll like put the commit message I want mostly first, and then I'll hit like R and reword that one, and then squash everything else into that. Or not squash, I'll fix up everything into that so that I can actually meld it into one nicely formatted commit message. So let's take a look at what this actually looks like. So all you're doing here, this is in your editor, mind you. This is in like TextMate or Atom or whatever else. Yes?
Squash and fixup can work on more than one. You said a couple and then you said
correct.
Several.
Yeah.
So it does.
Correct. We'll see, and we'll see how that works. So this is just like text that you can change, right? So what you'll do is you'll say like, when you look at this first one, I like that. That's a good commit message, and I like those changes, but it wasn't quite right. So I'm gonna leave it. I want to pick that. I want to use that commit. When I look at this next one, I like that update the comparison text. It was something that I needed to do, but I forgot that that we had an issue for that, and so I want to add the issue that it fixes to the commit, so that when I push, that issue automatically gets closed. So I want to reword this one. Then I look at this one and I'm like, well, actually I want to be part of this first commit. So what I actually can do is just move this line and switch them around. So I can move this line right under here, and then I tell it to fix up, right? So combine all these changes into this commit. Then we'll look at, I hate display bugs, I already want to reword, oh no, that one will move again, we'll fix up. Better markup for container. That one had an issue too, I want to fix that, so I want to reword that. And then these last three are all just fixes to that display bug, right? So I'll move all those up and fix up. So all of the changes from all this stuff where I like committed a bunch of junk are just all those changes are going to roll up and use this commit message, right? And then I close my editor. It opens this because I said I wanted to reword this. I add my issue that I fixed. This other reword that I wanted to do, I add my issue that I fixed. Boom. Now when I look at my git log, fixed display bug, looks awesome, right? It looks like I was super diligent about what I did. And here's the awesome part, is all those old commits still exist in my ref log and in my repository. But when I push, and I only push this branch, none of those get pushed up to the server, so no one actually needs to see how terrible I am. But if I ever need to get back to them locally, I totally can. It's my little dirty secret that sort of hangs around my repository. But to everyone else, it looks like I'm super awesome. So that's an interactive rebase. I highly recommend you try it. What an interactive rebase says to me is I can be much more free to commit at any time. And then before I push, I can actually reorganize my thoughts and push up those to the server. So I'm not scared to commit all the time because I'm like, what if this isn't quite the right thing? And then I do some more work, and then you end up with these giant commits that cause merge conflicts and are hard to resolve. Like, keep your small, tiny commits, and then you can combine things later. If you realize you did something wrong, you can fix it before you push it up to the server. Okay, that's an interactive rebase. The last thing I want to touch on is blame. So we can spelunk in the repo to find out who and why. This is awesome for me, especially when you're contributing to projects that you're either new to or have had other people working on them for quite a while. I'm working on a repo and I see this method right. It was status call function, like what? what in the world, like, why do we even need a status callback in this thing? I don't get why this is here. How many people have run into this, where you're working on some code that other people have written, and you're like, well, why? Why? Why is this even here? There's probably there's two reasons. One, there's a good reason that it's there, or there's no reason that it's there. But how do you know, right? How do you find out? This is where get blame comes in. So we get blame libindex.js. What ends up is this beautiful little output of our file, and then the commit, the last commit that changed that particular line. Amazing, right? So let's zoom into that thing that we looked at. So this is our thing that I didn't know about, and I looked at Max. I got Max. And this is my commit shot, right? So then I can get show that commit shot, and I get the diff for that commit. So I can actually see, like, why was that change introduced in a whole bunch of stuff? Was it, like, let me look at the commit message. Maybe that, so make index, I'll use status to speed it up. Oh! So now we have a status callback for asynchronous stuff to speed up the initial call. Got it. Cool. That's great. We can actually take this one step further, and if you use GitHub, which, you know, I recommend, but whatever. Whatever floats your boat. When you're looking at a file, when you're looking at a blob on GitHub, well, hey, cool, blame. And there's a little blame button. When you add it, or when you click it, we get this. So we have our set. We see this the same commit, just a shop. We get the little avatar, so we can see his face next to a cat, so I'm not that angry at him. And then we can click on that commit, and we get to, again, this is just looking at the change. You see a little bit more nicely formatted commit message. But there, we can take this one step further. If you actually use GitHub and use pull requests, boom, that's the PR number that introduced this commit, that introduced that change to that file. We can click on that number, and now we see the pull request. So we can not only just see the commit, the specific commit, and the commit message for that change, we can actually look at the pull request and the discussion that went around introducing that change, which is super valuable in beginning to understand the code that was written. Very important, which is another reason why pull requests are great, because you can spelunk all the way back through your code to see what changed and when introduced that. Super great. So again, we talked about trees. Every commit, everything that we do in Git is just a snapshot of a directory. We learned how to reset to move head, the index in the working directory. We learned how to save stuff that we're doing now for later. We learned a little bit about the ref log. It's the history of your history. Some interactive rebases to look super organized, and then blame to find out who and hopefully why your repository changed. So, any questions? I'm that good? Sweet. Thanks, guys.